Hello programmers, welcome to the video. We will be solving day 15 of Leetcode daily challenge. Today's question is adjacent increasing subarray detection 2. I think it's part 2 of yesterday's problem. Yesterday was adjacent increasing subarray detection 1. Today is adjacent increasing subarray detection 2. Okay, it's a medium question. Okay, let's directly jump into the problem. Let me grab my pen. Yeah. So here also we have given an array nums and nums length is given an array nums of an integer. Your task is to find the maximum value of k. Okay. So yesterday, remember we have given nums and k. Here we have to find the k. Okay. For which there exist two adjacent subarrays. Okay. We have understood the subarray part and adjacency part yesterday. Okay. Of length k each, such that both subarrays are strictly increasing. Specifically check if there is two subarrays of length k starting at index a and b, where a is less than b, where nums of a to k minus 1, b to b plus k minus 1 are strictly increasing. Subarray must be adjacent, b equal to a plus k, same condition as yesterday's, and return the maximum possible value of k. Subarray is continuous non-empty sequence of element within array. Okay, great. So yesterday, remember what we have done? We have created an array of increasing count. Okay, increasing length of the array. So we will let's say take this example number 1 and we will start from here. So let's build that first. So for 2 it's 1, 5 is greater than 2, so 2, then 3, 4, 5 till 9, then it will be reset to 1, 2, 3, and then for 3 it will be like 1 reset and then 1 reset. This will be our array. Or here we have in the previous question we have given the k and we have to find the index of the k, that if that exists, and k after k jump we will check if this exists and both of the elements of this increasing subarray will be like greater than equal to k, then we found the answer, we return true. Okay, otherwise we return false. Yesterday question was like boolean question. Today we have asked to return value of k. Okay, maximum possible value of k. So we have to find what's the maximum possible value of k, and k can be like yesterday remember we have discussed that 2k should be less than equal to n. Okay, and greater than 1, right? So k will be like less than equal to 9 by 2 around n greater than 1 equal to 1. So it's a k range, and if I search for k, like if k equal 1 is possible or not, then 2, then 3 for 4. If I directly do the searching, it will take off n time for me to search, and for each search we have to find that possibility or not in this array, which will again take off n time. So it will be like of n into k problems. Okay, and k is order of n, so of n square will be the time complexity of the solution if we do brute force way. So we have to optimize it. Okay, so I think binary search will be like more optimal here. Why? So let's start at k equal 1 and let's go till k equal n by 2. Okay, k will be somewhere here, in between, right? Our answer will be somewhere here. So let's take this is answer our, let's assume this is our answer, this point is our answer. Okay, great. Okay, let me change the color now. Okay, so before this answer every case possible, before this answer everything is possible, after this answer nothing is possible. Simple. So we have divided this array into two parts. One part is completely like possibility. Here all the k is possible to make an longest increasing subarray and with these k elements, and for these all elements we don't have any possible answer because this is the maximum, this is the max, that's why it's answer, right? Okay, so what we will do, we will like search for k equal to 1 to k n by 2. This is our highest searching and this is our lowest pointer. I will point lowest here and highest here, and it will become our search space. In this search space what we will do, we will find the mid and we will check if it is possible. If it is possible, then like in this case if it is not possible, then what we will do, we will reduce the high pointer here, so our search space will be this one. Okay, and again we will search a mid, so it will be like mid in second iteration, so I will make it as mid 2 to explain you. Okay, this mid 2 is possible, right? So we will reduce search space like low, we will move the low to here, so this will be our search space. This using this method we can always make sure that our search space reduce and we are like going closer by to the answer. Okay, at the end we have only one pointer left and it will be pointing to answer. Okay, because if there is no answer then it will be like low equal to 0, we will point at 0. Okay, so there is no answer, but that's not the case, right? Low should be 1 because there k equal to 1 is always satisfied, one element is always there, that self one length array is always like strictly increasing and adjacent, right? So at least we found the answer. We will find k equal to 1 to k equal to n by 2, and between them we will find the answer and we will do binary search. So let's quickly take care that what will be the time complexity of the problem. So time complexity will be this problem, we are searching n for that increasing subarray which we will create. Okay, it will take order of n space as well. This is our space complexity, order of n. And for time complexity we are searching this array how many times? Log k times, log k times. So k is here n by 2, log n by 2 times, which is time complexity of n log n. Okay, which will be accepted easily. Okay, so let's quickly code this problem. So after coding it out you will be like more clear what I am trying to explain here. Okay, so let me take int number, n is variable, so number dot size. Okay, we have constant till 10 raised to power 5, so n log n will be accepted. Okay, great. So we will make a vector of int increasing subarray, something like this, and it will be size n, base value is 1. We will make a for loop to count, we will start from 1 I plus plus. We will do if nums of I is greater than nums of I minus 1. If it is greater than previous element, then what we will do, we will increment this our I value to increment of I minus 1 plus 1. Okay, previous value plus 1 to I will increment. This is our for loop. After completing this, let me make a function private. Okay, and what it will do, it will be like same as yesterday's problem. It will give me this computed vector and it will give me k value, and I will check that it's possible or not. So is possible, let's name it is possible. I will give it vector of int, pass it as reference, increment and int k. Okay, I will pass these two elements here and I will check if it is possible or not. How I will check? So I will check, I will loop through this possibility array like increment array. Let me make here int n equal to increment array dot size. Okay, I less than n minus k I plus plus if increment array of I is greater than equal to k, and then increment array of I plus k, like I will be jumping k steps and will checking if it is greater than equal to k, we will return true, otherwise no, we will return false after this completion of this iteration. Done. So possibility sake, now I will make two pointers, low pointer at 1 and high pointer at, let's say, n by 2. Okay, if n let me take example, if n is equal to 6, then what will be the answer? N by 2 will be 3. Okay, so k can be as makes as 3, right? In n equal to 7 case, then n by 2 will be 3, and can in the 7 length array, 1 2 3 4 5 6 7, yes, 7 length array, we have the 3 and 3 increasing max. We can't have 4 plus 4 increasing, so k can't go to 4, so max range of k will be 3. Okay, great. So n by 2 will be sufficient. I think it will work. We will do a binary search while loop where low is less than equal to high. We will check it. We will create a mid pointer which will be low plus high minus low plus 1 divided by 2. Yeah, I will explain why I am doing this high mid after this implementation. So if I will check is possible of increment comma k. If it is possible, then we will increase our low to mid plus 1. Otherwise else we will do high equal to mid minus 1. At the end we will check what pointer to use, low pointer or high pointer. Okay, so let me walk you through this example. So let's say we have a length length of 3 at the end, like low is pointing here, high is pointing here, and mid will be something in between. Okay, because at the when we have 3 sides, then low mid and high mid will be same, and this low mid and high mid will be useful when we are doing like to even length, finding mid for even length. So let's say we have a array of 4 elements. Okay, what will be mid? This is our low mid and this is our high mid, bigger mid. How to find the low mid? We will check low plus high minus low divided by 2. We will do, and I will be pointing to here. If I am do low high minus low plus 1 by 2, then I will be pointing to this high mid. So here I have taken high mid. Why? Let me walk you through example. So let's say we have a three length array. There is this mid, this is low mid, this is high mid. So no, there is no issue. And if I do this is possible calculation on this mid pointer, so what will be the case? Let's say it's the possible. Okay, then I will do low equal to mid plus 1. So low will be here, high will be here, correct? In the next iteration, what will do? This is the mid. Obviously if low and high is same, then this is the mid, and this will say that no, this is not the answer, it is not possible for this k value. So high will be moved to high minus 1 at the mid. So we have to choose high at the end, not the low, first of all. Okay, let's take example of, in this example let's take this mid is saying that no, this is not accepted, this mid is not possible. Okay, so let me change the color for you. Okay, so I will make again 3 size array, and I will say this is first mid 1, and it will say that it's not possible. Then what we will do? We will move to high to here, and low is already here. Okay, and mid 2 will be here. Okay, and then what we will check? Yes, it is possible. It's possible function will give yes, it is possible, because low we are starting from 1 at least, so it is possible always. Okay, and then what we will check? If it is possible, then we are doing low equal to mid plus 1. So low will be moved to this danger zone, but high will be remained here, and after low is crossed high, we will be calculating for high. Correct, great. So now let me explain you low mid and high mid concept with array length of even length of array. Okay, this is odd length of array we have explained. So let's go ahead and create a even length array with 4 elements, starting with 4 elements. This is our high mid, this will be our mid. So this is our mid, first mid, this is our low pointer, this is our high pointer. We will check if it is possible or not. If it is possible, then what we will do? We will move low pointer to here, and it will be becoming one step wala case, and we have already solved it. Okay, great. If it is not possible, then we will move high pointer to here, and we are left with 2 array element. So I will explain now with 2 array element how we will be solving it. Okay, so let's say we have 2 array element, low pointer here, high pointer here, and what will be the mid will be this high pointer. Okay, because there is 2 mids, so we will take always maximum value. So we will check if it is possible or not. Yes, it is possible, then we will move low to high plus 1, and low will be in danger zone, and we will be using high here. Done. Okay, if it is not possible, then what we will do? We will move high to mid minus 1, which will be here, and if it is same, and mid will be the same, and it should be possible obviously, and after it's possible, we will move this low pointer ahead, and high pointer will be our answer. So we will be checking high pointer only. So I have explained you using dry run examples. Here also like we have to pass mid here. Okay, so at the end we have to return hi. I think this should work if we haven't done any mistakes. Yeah, both the test cases passed. Let's submit this problem, and yes, it's accepted. We have now 18 days streak. Great, we will try to continue it. Happy Diwali to everyone. If I am not able to upload any video for upcoming some days, I am going home, so I will try my hard to like post a video, but if it is not possible, then it's like last video before Diwali, so I will say Happy Diwali to everyone. Bye, take care.